Right. 6. Okay, so this is what I'm doing. All right. So what are we doing? We're talking about the abacus, and we're talking about the abacus because I like the abacus. I like the abacus. Ah! Okay. So here's my abacus, and we're going to be counting. We're going to count 1, 2, 3, 4. When we count to 4, we notice that we don't have any more beads for 5. Well, the thing about adding 5. Hi, Sarah. The thing about adding 5 is we have the top bead. Now, what are we doing here? We're actually counting on the abacus, and when we're counting on the abacus, it's like moving the beads. And so what it is, we have 4. How do I know? These are the beads that are being counted because this is my horizontal bar. This horizontal bar is my beam, and this beam is what we know that we count on the abacus. So again, when I count 1, 2, 3, 4. So just as we write it, we have 1. Whoa, that didn't work. We have 1, and then 2, right? We have 2, and then 3, and then we have 4. Notice this, we have 4. Where's my 4? So we have 4. That's 4. Okay, I'm going to reset and I'm going to do it again. That's 4. So the reason why it's 4 is because these beads are touching this beam. When the beads are touching the beam, then we know that it's being counted. If it's not touching the beam, like these ones here, that's not being counted. So notice we don't have any more beads. Hi, everybody. Welcome. Come on in. Come on in. We are talking about the abacus. So if you notice, none of the beads, there's no more beads to here to go to figure to 5, right? We need to go to 5. Now, how do we go to 5? We go to 5 by the top bead. This will always be 5, no matter what we're talking about, right? Because if we look at it, this will be 5, that's 5, this is 5, this is 5, and this is 5. So all of these beads, if they're touching this horizontal bar, this is counted, and these are called 5. So I'm going to reset my abacus. I was going to reset my computer. I'm going to reset my abacus. And so notice I have none of the beads are touching the horizontal bar. Because the beads are not touching the horizontal bar, then I know that this is 0. So when we count 5 and then 6, how do I know that this is 6? Because all of the lower beads has a value of 1. So when this is the value of 1, we can have 7. How do I know? 5, 6, 7. So it'd be easy to see that we do 7. And we know what the number looks like, right? So that's 7. 5, 6, 7. If you notice, we have 5 and 2. 5 and 2 is equal to 7. So then 8 is this. 5, 6, 7, 8. And then 9. Well, what's 9? Well, 9 is just this. So we have 9. This is 9. That can be 9. Notice that all the beads are touching the beam, the horizontal bar. And then this is 9. So when we look at it, it's easy to see that this is 9. Just like it's easy to see on a die, right? I should stop saying right. So it's just like seeing on a die, this is 5, or this is 6, or this is 2. So in this scenario, depending on what sort of manipulatives that we're using, this is very common in kindergarten and first grade, is to use the die. The reason why they want to use the die is to start to let the kids understand how to supertize. And what is supertizing? Supertizing is when you look at something and you know what it is, right? Instead of counting 1, 2, we want to be able to just look at it like this and know that this is 2. So we could do a comparison when we do 3. This is 3. 1, 2, 3, 1, 2, 3. Oh, 1, 2, 3. So that's how we know what this is. So this is 4. So my die, I have 4. 1, 2, 3, 4. 1, 2, 3, 4. Now the difference is on the abacus, that will be 5. That will always be 5. And then on the die, that's 5. We have 6, right? And then there's 6, so that's 6. But if you notice, when you look at the number 6, sometimes we have to separate it. Hi, Andy. So, welcome everybody. So if you notice, sometimes I have to split it. So it goes 1, 2, 3, 4, 5, 6. But we know that there's 3 and 3. On the abacus, we actually don't need to worry about that because we have 5 and 6. So we know that this will always be 6. And then we have 7. So we have 7 and then 8. But then again, there's no more 8 on the die. I mean, this is only a 6-sided die, right? So that's the difference between the die and the abacus. So we're back to 9. So we have 9. And then we have 10. Well, we notice that when we write 10, we have a 1 and a 0. Same thing on the abacus. The way we write it is the way we see it on the abacus. We have 1 and we have 0. Does that make sense? Anybody have any questions? Let me know. So we have 1 and a 0, just like we have when we write it. And then we have 11. We have 11, 12, 13, 14, right? 14 because we have 1 and 4. And then we have 5. We have 15. Sorry, we have 15. Then we have 16, 17, 18, 19. And then what's after 19? It's 20. How do we know what 20 is? Because we know it's a 2 and a 0. Because we know it's a 2 and a 0. So how do we write this? How do we know what these are? Well, if you notice, there's these dots. Let me see if I can. There we go. There's these dots. These dots tell me that I want to label my ones. So this is where I want to put my ones. You could put it here, or you could put it here. It actually doesn't matter. As long as it's being labeled that where we're going to start counting. So in this specific abacus, I only have 2 dots. You can choose either or. Depending on how big your number is, you can start here, or if you want to, depending on how small the number is, we can go here. So the next step is to know that if this is here, right, if this is my ones, this is my tens, this is my hundreds, and then this is my thousands. Anybody have any questions? Let me know. Go ahead and put it in the chat. So after the thousands, we have 10,000. So when we look, we have our number. Let me know in the chat, what do you think this number is? Let me see if I can change that. Oh, much better. So let me know in the chat, what do you think this number is? If this is the ones, this is the tens, and this is the hundreds. So what we're doing is we're reading the abacus right now. Everybody needs to start from reading the abacus when we go down this journey. So the idea is to understand that if we start here, this is 5, right? This will be 5, 6, 7. So we have 5, 6, 7. So that's 75 right here. And then this is 2. So this is 275. When we write it out, this is what it would look like. Oh. That didn't work out. Okay, we have 275. So again, it looks like this. It goes 275. Now, how do I know? And the top bead always has a value of 5, and the bottom bead always has a value of 1. So when we read the abacus, we will know that this is 5. And then when we count, it'll be 5, 6, 7. So another thing that the abacus does, it actually gives there's a kindergarten skill of counting on. So when the kids count on, what does counting on mean? The kindergarten skill of counting on is being able to count not from 1. So abacus introduces the idea of counting on because they have to start from 5, 6, 7. And then there is 2, right? This is 2. How do I know? Because it's touching this horizontal bar. I should center it more. This horizontal bar is what makes it count. So now we have 275. So here is another one. Oh, thank you. Good, Becky. Well done. So the first thing we need to do is we need to understand how to read the abacus. So the next number I want to try is this. What number do you think this is? Let's do that. There we go. That's the number I'm looking for. So what number do you think this is? If this is my dot, right? My dot is right here. This will be the ones, this is the tens, and this is the hundreds. So, yes, Becky, that's exactly what it is because it's 418, 418. And that's the way we read it. So when we do, or the next thing here, let me give you good job, Leanne. So the next thing is, well, what if I decide to put my ones over here? So if this is my ones, this will be in the decimal places. So what does that mean? Well, this will be 0. And then my decimal place, if you notice, sits between these two columns. So because it sits between these two columns, my number would be 418. Because it goes backwards, right? We know from the decimals we have our ones, our tenths, our hundredths, and our thousandths. Good, Jim. Well done. So, Anybody have any questions? We're going to continue on reading the abacus before we start going into adding, subtraction, multiplication, and division, depending on how many people are talking. Sometimes I go to division, sometimes I don't. But, oh, I wonder if NCMS is here. It might be late. Anyways, because I do have some multiplication. There was a request for multiplication, but if not, I will work on adding and subtracting first. Because the first thing we need to do is understand how do we add and subtract. Now we understand how to read the abacus. The next thing would be to figure out how to add and subtract. Now, the one thing I did was I do have a book for preschoolers. And the reason why I did this is because I noticed in school, not in school, in the abacus world, we kind of neglect the preschoolers. And what I wanted to do is I wanted to introduce abacus to preschoolers so they know how to count from the get-go. Right? So just like when we introduced the die, we introduced like other, what do you call it? We bring in other bring other manipulatives, but nobody talks about adding the abacus as part of the curriculum. And that's what I would like to change. I want to be able to provide information on how to use the abacus as well as count on the abacus, just like how we do here. So we have 1, 2, 3, 4, 5, 6. Same thing on the abacus. That would be 6, right? So the difference is that we don't see the quantity, right? We don't see the amount that's being used here. So we have that, and then in the book, this is what the book is for, and it was to show the difference between the numbers, and it only goes from 0 to 9. So when I got it, when I did is I have my picture, so I have my represented abacus, and then I have my symbol, which is these, right? These numbers are actually symbols, just like letters. And I have a picture of a real abacus. Hopefully when going through this book, they will purchase an abacus either from me or from Amazon or wherever. I like this one because it's very colorful. The one I have, if the kids are older and it's too much color or if it's too overwhelming, I mean, there's one that's a 13 columns, but there's also this one is a 7 column. I liked it because I've been working with the single colors for a long time. This is a single color, and this one is 13 columns. It's the same concept, right? But notice it's not as colorful. And with my online class, it's harder to say, move the brown bead, because they're all brown. So I like to use the colorful one just so it's easy for me to say through the Zoom calls or through any of my classes to move the bead. Right? To move the green bead, that's the one bead, right? If I want to move the one bead and I have one here, move the yellow bead because that's one bead. Okay? Now, this is still the same concept. What is that? Well, and it's still the same concept of the colorful one. It's just monotone. Now, if you notice, there's these dots. They all have dots, which is kind of nice. The dots help label and index, like know where your place value is. And one person was asking, why do you do every 3? Well, just like in writing, just like how we write, we have these group separator. So if we were to do $1 million, $1 million, that reminds me of Austin Powers. So if I do 2 million, 5, 7, 4, 3, 148, right? Notice I have my commas. So in America we use commas just to understand where the concept is. It's the same thing with here. So we have, if this is my ones, I can do 8, I can do 4 and 1. Then my 3 is my thousands. Notice that's my thousands. So I have thousands, then 4, 5, and then 2 million. Oh yeah, there we go. So it's 2 million. So as we write it, we could see it, and notice the dots line up with the group separator. I hope that makes sense. But yeah, I was trying to figure out what the name of it. And these commas, right? It's easy to see. It's nicely to see that this is 2 million, and it's the same thing when we read it on the abacus. This is 2 million because the dot is over here. If I choose that this is my ones place. So that's why there's so many dots. You can use this dot and then you have a huge number, Or you could start over here and have a really small number. There's another abacus, which is this one, and this is more competition abacus, and this is 23 columns. Thank you so much for the likes. This is 23 columns, and this is usually for competition abacus. Now, I don't teach competition abacus. You can if you want to, but my goal was to make learning fun for the kids, right? If they want to go competition, it's up to them. If they don't, that's perfectly fine too. But my goal was to make it fun. And one of the things was to make it fun was to modernize abacus. Now, what do I mean by modernizing? Well, now I'm getting to a point where I'm trying to add in activities, and I try to be getting the kids to write a little bit. So I have tracing. So there's a tracing number, and then tracing the number 2 and understanding how the 2 works, and then trying to find the abacus. So this book is specifically abacus for children. It's specifically made for the abacus, whether they're learning their numbers, for children learning their numbers. And so it keeps going, and I have other activities where, like, this one's a follow the path, so they color in whatever they want. They get to choose their color, their key color, but then I want their number to follow and find what number is at the bottom. So a lot of it is bead recognition and number recognition. This one was for making sure that they understand what the number words were. So this was very much towards directing the children to understand what the number means, what it means by the picture, and then what it means on the abacus. And then we go forward into lesson 2. Lesson 2 is about 5 to 9. The reason why is because when we look at it, this concept of 5 is, the concept of 5 up here is being used when we add 6 and 7 and 8 and then 9. And then again we have 10. Which is another thing, like, I actually made an epiphany of. If you notice, if you look at the abacus, you know that when we're rounding, you can use the abacus to help you figure out if you need to round up or need to round down. So if we have 4, that's the bottom bead, then we need to round down. If we have the 5, anything 5 and above, anything that uses the 5, we actually round up. So I thought that was really interesting about, the abacus, about rounding up and rounding down. So when we have 7, right, we know we can round up because why? We're using this 5. So I thought that was another epiphany that I made. And the other thing was, trying to get abacus to relate to what we're learning in mainstream math. Thank you, Michael. So, welcome everybody. Welcome. Let me know if you have any questions. Just going through some of the activities of the workbook for children that you want to introduce to abacus. And one of the things was to count forward, and then the other one was to count backwards. And it's easy to count forwards and backwards because if you notice, we count forward, we add the 1. So we add 1, 2, 3, right? We're adding 1 to count forward, and then they will have to know that this is 5. So, what grade do I teach? I don't teach a specific grade. In abacus, everybody has to start from learning how to read the abacus, and then can go forward to, if I am lucky, I will have students that are all the way from 3 to 16 and maybe to adults. For those people that want to learn, it's heavily into, if I really need to categorize it, it's really heavy into maybe second grade because we can do adding and subtraction on the abacus, like 2 digits, 3 digits, 4 digits, 5 digits, and that's where we do a lot of our adding and subtracting. But then we also do multiplication, division, and I think that's in 5th grade. So it kind of ranges between, like, where everybody is. But if they go through the curriculum, if they go through the abacus curriculum, I mean, my children, I have 3 boys, and they all went through the abacus curriculum, and it took them probably they started when they were in preschool, and they went all the way to, I think, 2nd grade, but they knew their multiplication division. So it really does depend on when the kids pick it up, but we all have to start to understand how to add and subtract on the abacus. I do have my classes, so I do have this one student. He's in 1st grade. He's 7 years old. And so we started off with doing bead recognition, and then the next week we actually started going into adding and subtracting because by then he's already doing adding and subtraction in school. So I don't know if that answered the question, but it's a little elusive because we all have to start from learning how to read, and it just depends on the focus of the child. So for my student right now, I do have younger students that will go into understanding like the bead recognition and the numbers. And then I have my other students that they already know how to count, so I need to push them through and getting them into adding and subtraction and then multiplication and division. So I hope that answers it. So yeah, yeah. So this right here, it's easy to see that we're taking away. So if I start from 9, all I got to do is take away the one bead. So if I take away the one bead, notice I'm actually taking away the one bead, and the kids will see the difference between subtraction. So when I take away 1, they know that I'm removing it from the horizontal bar. So all these beads that are touching, this is 7. So because this is 7, and I want to count backwards, I know I just need to take away the one bead, and I know this is 6. So I like Abacus because it's a gentle reminder on what the numbers are, as opposed to we just see the symbols, right? Because it's difficult to understand, depending on how old the children are, it's difficult to relate that this 1 means the actual item of 1, right? And so when we do 4, they know that this is 4. So using the abacus, it's nice to have a gentle reminder of how things are working. Then afterwards we do what number comes in between these two numbers. And this is again very heavily on trying to get the abacus, to get them to understand how to read the abacus. And so from here we can talk about the bigger than and less than. Hi, green pill. Hi. Welcome back. And then after understanding like the big, what's bigger and what's less than, then we actually go into adding and subtraction. Now, the reason why I have it here where it says +1 thumb up, what I want to do is I'm trying to make sure that the kids know that the second add-in is what we need to focus on. So here is my question, 1. So I have 1, right? This is 1, and I need to add another 1. The idea is knowing that I need to add this one bead, and my answer is 2. So when we go here, my question starts with 2, and I need to add the 1. So I only add in the one bead. Notice it's the one bead. Sometimes the kids get hung up and they think that this is 1. No, it depends on what is there already on the abacus to figure out if we need to add the 1 or not. Now, the reason why we focus in on the process and not the result. So one of the things I was doing is I was researching on how other people would teach addition and subtraction. I've been dealing with Abacus for more than 20 years. So it's been a moment since I've actually done learning adding and subtraction on the just regular mainstream math. Did I have to help my kids? No. I didn't have to help my kids because they already knew how to do it. So I've been very removed from how to add and subtract. So when I was doing my research, one of the things that I noticed was there's one video was like they were focusing on the result. So we had the question 5 plus 3, and I was like, okay, 5 plus 3, and they said, okay, it's 8, yay, it's 8. So we have 5, and if you notice, if I put this on the abacus, we have 5, and then plus 3. Let me move that over. So we have 5 plus 3. So notice I keep asking, do I have enough beads? Yes, I have enough beads. So all I got to do is just add the 5 and I add the 3. Not a problem. That's perfectly fine. So now we have 7 plus 1. That's not a good 7. That's a better 7. So I have 7 plus 1. And then again, the video is like, it's 8. Yeah, it's 8. Let's do the happy dance. And I'm like, yeah. All right. Now on the abacus, we could do that too. We have 7. Let me see. We have 7, and then we have plus 1. My question is do we have enough? Yes, we have enough to add the 1, so all we got to do is just add the 1. Now, the next question was like, wait a second. Now, the next question was, if you haven't thought about it, the next question was this, 4 plus 4. Now, this is a little bit loaded. Why? Because in Abacus, we don't memorize the doubles. We do not memorize the doubles. But in regular mainstream math, we memorize. I remember memorizing the doubles, and then I had to memorize like doubles plus 1, and then doubles minus 1, and so forth. These were all strategies that we were either do it on our own or we had to teach or what have you. My kids don't know their doubles. They know how to use the abacus. So what's the difference? Well, we know that it's 8, right? Now, the question is why is it different? How is Abacus different? Well, if you notice, and I'm going to use this one over here, I'm going to add 4, right? This is the 4 I added, which is great, not a problem. But then we get to this 4, and this is where it's different to mainstream math. Because in mainstream math, we focus on the answer. We focus on the result. But in Abacus, we actually focus in on the procedure, the process. So the question is how do I get the 4? Because I don't have any more beads to add the 4. Well, okay, so now we got to think about the next lesson, the next phase of Abacus. In school, we are teaching children how to make a 5. To make a 5, I have 5 blocks, right? 1, 2, 3, 4, 5. I can see it. If I decompose it, there's 4 and then there's 1. If I decompose, there's 2 and 3. If I decompose, it can be 2 and 3 and 2. If I decompose it again, it can be 4 and 1. So these are all the ways we can decompose 5. Now, it's critical information for Abacus. Why? Because we actually utilize that knowledge and we strengthen the idea of understanding how to make a 5. So when we make a 5, we do 4 plus 1 is equal to 5, or we do 1 plus 4 is equal to 5. When we do that, now the next step is to, and this is interesting because Abacus is the gateway to complex math. And you'll notice that I'm going to start using math terminologies that we actually don't use in Abacus. One of the math terminologies, because now I'm talking to adults, right? We're going to isolate this variable. This is a variable. I mean, if I changed it to an x, right, it would be a variable. But the idea is to isolate this number. We're going to isolate the number, and we're going to take this 1, and we're going to move it to this side of the equation. Why are we going to do that? Because if you notice, if I do a 4 equals to 5, the equation is not balanced. So to balance the equation, I have to take away the 1. Why are we doing this? Because we got to figure out how to use this 5. Now, in Abacus, when we know how to use this 5, that will be one ingredient to a souffle. It'll be one ingredient to a cake that we need to remember. This is the one thing that we need to remember is we need to remember the pair. So in Abacus, we actually have a gentle reminder that if I want to add the 4, right, the reminder is this operator. If I want to add the 4, then the motion of adding the 5 and then take away the 1. So here's my question. Right now, when we put it into play, what we're going to do is we're going to substitute. These are big words. We're going to substitute this 4 into here. So how to substitute it, we're going to take this information and we're going to stick it into here. So as we substitute it, that's how we do adding on the Abacus. So what it says is I'm going to add the 5 and I take away the 1. And my answer is 8. Thank you so much for the likes. Did that make sense? So those are like math terminologies that I was trying to figure out because in Abacus, I've been doing Abacus for more than 20 years, and talking to parents and adults is different than talking to kids, right? So talking to kids, they just know that we need to plus the 4 is equal to plus the 5 minus 1. But showing how to do this, right, we have to isolate this 4. We have to isolate the variable. When we isolate the variable, then we substitute this information into here. So if I rewrote it, it'd be 4 is equal to plus 5 minus 1. That's what we'd be doing. It's a little complicated, but that's the idea. But notice we don't need to memorize the 4 plus 4 because that's a loaded question. Now, what does that mean? Well, when we say we got to do a 2 plus, let's do a 2 plus 3. 2 plus 4. If we do a 2 plus 4, what are we going to do? Well, we know our doubles, right? So what are we going to do? We're going to do 4 plus 4 and then take away the 2. Or you do 2 plus 2 plus 2. I mean, it gets a little complicated. I mean, it's great to be able to have number sense and to be able to manipulate the numbers. Or what we could do is we add the 2, and then we see the 4, and we go back to what we remembered, which is plus the 5 minus the 1. So all we got to do is plus the 5 minus the 1. And my answer is 6. So it's different. right? I mean, it's a different perspective. I'm not saying that I'm not saying which way is bad. I'm just saying it's just different. Because in school, we're starting to teach the kids to make a 5 and make a 10, and then learning the doubles. Whereas in Abacus, we make a 5, but then we utilize it. We actually strengthen the concept of understanding how to use a 5, right? And it's the same thing with how to make a 10. And that's a huge thing right now, like how to make a 5, how do you make a 10? And if you notice, that's all they do. They just stop at the decomposing of the 5. That's all they do. They just stop right here. But in Abacus, we take this concept and we take it to the next level. And I totally agree with I totally really think it's an interesting way of doing things. So going back to here, this is, I mean, that's why when we learn Abacus in this book, we talk about only the simple, meaning we only do math equations that doesn't require formulas. This is a formula. Plus the 4 is equal to plus the 5 minus 1. That's a formula. We get to a point where we start to utilize it. But for this beginning book, the Preschool Abacus, and all the other beginning introduction books, I separated it to just be able to look at the added. And that's the reason why I had that. I wanted to only to focus on the second add-in so that it's easy for the kids to see what we're trying to do. So here, this is 5, right? In the 5, we have 5, and then we want to add the 1. So we add the 1. And then my answer is 6. And then we do the same thing. We do plus the 2, right? After 1, there's 2, and after 2, there's 3, and after 3, there's 4. But then after 4, we do the takeaway, which is minus the 1. Because again, I want to show them the balance. If you add, you need to know how to subtract. So when we have our question here, we have 2, and we take away 1. So our answer is 1. And then our next one, right? And then we do minus the 1, we do minus the 2. The reason, it's not negative 2. We don't do negatives in Abacus. What we're doing is we're taking the concept of removing. So that's what this means is I'm going to take away the 2, not negative 2. And that was the one thing, like, some people get hung up on this, and it's a different way of thinking. Yeah, because we don't do negatives in Abacus. We do everything's positive when we do the result, when we have our answer, but it's never a negative, because then it doesn't do negative on the Abacus. But we do a takeaway. Let me know if anybody has any questions. And then again, we do minus 3, and then we do minus 4. After minus 3 and minus 4, that's when we start doing plus 5. And I broke it up into, okay, and when we add the 5, we can add the 6. Notice when we add the 5, this is the only thing that we need to do. We need to add the 5 and take away the 5. Add the 5, take away the 5. And then 6 will always be 1 beat on top and 1 beat on the bottom, no matter what. So if we had 1, we could do 6, right? And notice it's 1 beat on top and 1 beat on the bottom. It's not these two all the time. It is 1 bead at the bottom. It doesn't matter which bead. So it's the same concept of adding 1. The idea is to be able to have the number sense to see the pattern. So when we see the pattern, welcome everybody. When we see the pattern, it's easier it's easy. But you notice that there's a pattern. So when we do a 6, it goes like this. So if we had 3 plus 6, it'd be 1 bead on top and 1 bead on the bottom, because we have to count the top bead, right? We have to count the top bead, and this would be 6. We're adding 6 here. Yeah. So after adding, again, there's subtraction. So after we add all the way to plus 7 and plus 8 plus 9, and then I added some activities, like this one is colored by number. And I thought it was kind of cool for the kids. This one is a puzzle. So you have to answer the question, and there's a puzzle piece. But I think I lost the puzzle pieces. There's another one. Let me see if I can find it. I have another puzzle that I made. Oh, yeah. So here is an example where you answer the question, and then you find the answer that's over here. So after adding, there is subtraction. And that's the last chapter. That's the last lesson in this book. After you figure out, after that's all said and done, What we did is we finished off. I feel so. Oh yeah, we finished off understanding how to do the addition table, and I don't know if they give this out in school, but I noticed that what we're doing here is we're focusing on the second add-in. So if you notice on the second add-in, this right here is what we just covered, which is the simple, which means it's only adding and subtracting with no formulas. When we get to here, and it's also the same thing with the subtraction table, which is the wrong one. There's a subtraction table I created as well. And I'm trying to find that. And is this? Right. Okay, yeah. So here's my subtraction table. And it's the same thing, right? We don't take away a small number. We don't take away the big number from a small number. So that's why this is all blank. But if you look right here, 4 take away 1. When we look at 4, and we take away 1. Notice I can take away the 1, so that's why it's called simple. Same thing with here. This is still minus. This is the 5. So what does that mean? Well, when we started talking about making a 5, when we made a 5, when we made a 5, after making a 5, we need to also take away the 5. One of the things that I was mentioning is when we look at our formulas, when we look at the 5 formula, one thing to look at is if you think about it, 4 plus 1 is equal to 5. Now what we can say is plus 5. So if I did a plus 4 plus 1 equals to plus 5, that makes sense, right? And the reason why I do this is because, 3 plus 2 is equal to plus 5. Now the reason why I do this is because it's supposed to be assumed, if I do this, right, that this is pluses. But then we would have to explain the other side, which is the inverse. What does that mean? Well, if I do minus 4 minus 1 equals to minus 5. So now we're doing the inverse. If we do the plus on one side, we can do the minus on the other side. The reason why is so we can do subtraction. And again, if we isolate, when we isolate the variable, I want to isolate this 4. I'm going to take this 1 and put it over here. We can plus the 1. So now we're isolating the variable. And let me rewrite the question. So now it will be minus the 4 equals to minus the 5 plus the 1. What question would that be? So let's talk about 7. I want to take away 4. I cannot take away 4. There's not enough beads. I only see there's 2 beads. So to do that, I can utilize the 5. When I utilize this 5, I need to take away the 5 and I add the 1. So I take away the 5 and I add the 1. Notice I do it at the same time. Because why? Because we are substituting minus 4 with minus 5 plus 1. Does that make sense? Are we okay with that? Okay, so I just need to take a little break, a little breather, and it's so quiet because I'm the only one talking. All right, so when we have 7, sense made. Oh, good. So again, it's still the same thing. Like we don't look. Here's another epiphany I just made. When we learn our doubles, it's always a plus. It's never a negative. It's never a minus. How does a minus work for doubles? It doesn't, does it? So learning your doubles is only one way. It's only for adding. Oh my God. Okay, sorry. I was just making epiphanies because that's the thing, right? Like sorry. That was okay. So if you notice, when we're taught to memorize doubles, it's always going to be the plus. We never say, what's the minus 4 is equal to minus 8. We never talk about the other side, the inverse side of the doubles. I just cracked myself up. All right. I'm trying to mute my do not disturb. There's a lot of, okay. So, yeah, that's really interesting. Just like we don't have just like we have a multiplication table, but we don't really talk about a division table. We can talk about that later. But I noticed like some of the things that we talk about the number sense, it's only one way. And that's the interesting part. That's really interesting. There is no doubles for the minus or the negative. Is there? No, there isn't. Anybody know that? Okay, anyways. So we have our minus. When we do we're adding, right? When we know how to add, we will know how to subtract. And it goes hand in hand because if you notice, we have to be able to learn how to move between the two operators, right? The plus and the minus. I slowed down on these terminologies because we don't use this in Abacus. That's why I slowed down when I say specific math terminologies because I have to translate it in my head. What was I trying to say and how does it work in mainstream math? So that was one of the things that I'm like going down this path because if you notice, if you look at any Abacus videos that's on YouTube or even on TikTok, they always talk about adding the friends and plus the friends or adding the big friends or minusing the big friends and so forth. But they don't talk about it in the mainstream term where we start adding the 5 and how do we make it and massage it to make it work on the abacus. And so that was the one thing that my goal is to try to show how easy. And I don't know where everybody is. It would be good to know. But we in California, we teach children Common Core, and there was a lot of parents who were like, "Oh my God, Common Core is so difficult." But then when I look at it, Common Core actually makes a lot of sense because on the abacus we use Common Core. It's not like as explicit, right? Like there's a framework in abacus, so we have a framework to talk. In when we add, we only want to add this in the beginning. The simple, and then the question is do we have enough, and if we can do it, how else can we do it? So that's why we have the plus 5. Then the next one is making a 10. When we make a 10, it is this yellow right here. So in school we're teaching the children that 9 plus 1 is equal to 10, or 1 plus 9 is equal to 10. That's great. That's not a problem. Common Core is crazy until you get it, and then it makes sense, almost like this. Yeah, right? But see, that's the thing. Like, I didn't have to go through the crazy of Common Core because I already knew Abacus. And so I was like, oh my God, this is so like Abacus. And so then that's why I was going down the route like, oh, make a 10. That makes a lot of sense. But it stops right here. In mainstream math, it stops right here. Whereas in Abacus, we actually take it one step further. Why do we do it? Well, we need to figure out how to move the beads. And using the beads, it's a gentle reminder. Right? When we add a 4 and want to add the 9. So here's my question. I want to add 4 plus the 9. I want to add the 9. So what do? I isolate the variable. I'm going to isolate this 9. I'm going to take this 1 and put it over here. I'm going to minus the 1. Right? We understand that. So we plus the 9, right? Plus 9 and plus 9. These are the same plus 9s. We want to plus the 9 is equal to plus the 10 minus the 1. So again, what am I going to do? I'm going to plus the 10. This 10, another terminology. It could be called grouping. It could be called regrouping. It can be called borrowing. If we go, backwards, if we go, subtraction, or it can be called carry on, or carry on. What does this mean in Abacus? The only thing that this means is we're going to the next column. That is all it is. If I go to the plus 10, right? If I want to add the 9, I need to plus the 10, take away the 1. I plus the 10, I go to the next column. That's all it is. I go to the next column. I add the 10 and I take away the 1. So then my answer is 13. We could do it. We could do it anywhere, really. So if I had 400 plus 900, it's still the same. It doesn't matter. We don't say in Abacus 900 is equal to plus 1000 minus 100. We don't say that because now it's just redundant. What we do is we boil it down, and if we look at it, if I want to add the 400, right? 400. I add the 900 to add the 9. We take it when Abacus when we talk about abacus, we're only talking about the one bead when we go across. We take the number as a whole. So when we add, we're taking the 9 on the hundreds column. I need to move my paper. We add the 9. Hi, Micah. We add the 9 to the 100s column. So we add the 9. What are we going to do? We're going to plus the 9 is equal to plus the 10 minus 1. So all I'm going to do is plus the 10. I just need to go to the next column over. Next column over, I plus the 10, and I take away the 1. And my answer is, because my dot tells me that I'm at the thousands, so it'll be 1,300. I hope that made sense. Yeah. Yeah, I mean, it's really quite interesting on how simple adding and subtraction can be. I know we make it really complicated, right? Like one of the ones, where was my? I had one where, oh, I know where I put it. So one of the strategies was number bonds, and I'm like, how is that gonna work? So here was one of the number bonds, and I'll do it in different ways. Let's see if I can find the question. It was, oh yeah, okay. So she did it in number bonds. This is not to knock the strategy. It's just a different way. And so it was interesting how she was talking about it. So there was a number bond. We have 27, right? That's 1. And then we want to add 18. We'll do that. We'll do that. So what the teacher did was, I'm going to break these two up. I'm going to have a 20 on this side, and I'm going to have a 7. So what we did is we break it up, and then did it again here. We had 10 over here, and then we had 8 over here. Okay. And then now what do we do? So now what she does is she takes the 20 and the 10, and she adds the 2 together. I was like, oh, okay. So that's 30. I don't know. I don't know what happens after this. But I'm just gonna write 30. Oh, I guess she does this. I don't know. I'm just pulling from air. So then we take the 7 and the 8, or anyways, and then that makes it 15. And then she does it again, gives you the answer. So we add these two together, it's 45. Okay, that's fine. In the abacus way, when we do it, we have 27, and it doesn't even matter how we do it. We can do it this way, or we could do it 27 plus 18, plus 18. It doesn't matter. When we do it, though, however, when we do it, we always take the number as a whole. We always take this whole number like this. Okay? So we have 20, and we have 7. Now we have 18. We add 1, and then we have 8. So we add the 1, so plus the 10, plus the 10. And then now we add 8. How do you add 8? Notice there's not enough beats to add the 8. What do? We know to make a 10. To make a 10 is plus the 8 is equal to plus the 10 minus 2. So we plus the 10 and we take away the 2. And my answer is 45. Yeah, that's what we do. So, I mean, we could do, I mean, you know, there's more. In Abacus, we actually do more than just 2 add-ins, which is interesting, right? So one of the, here's another question. We can do 3 digits. Well, let's be exciting and do 3 digits. So I have, question is 301, let's see, 301, 110 minus 263. Now, it's common for Abacus to have more than just 2 add-ins, but notice we actually, in Abacus, we do not do this. We don't do the 1s first, and then the 10s first, and then the 100s. We don't do it that way. What we do in Abacus, we do 300 first. So I'm going to add the 300. I'm going to use my Abacus to cover up the number. I'm going to do 300, 0, 1. And then when I move down, I take this whole number as 110. So I have 110. 100 plus 1 plus 10 plus 0. And then I take away 263. So I take away 2. I take away 6. I don't have enough beats to take away the 6. What is another way? Another way is minus the 6 is equal to minus the 10 plus the 4. Spoiler alert, this is a two-step problem. This is a two-step equation. What does that mean? So I'm going to take away the 10. That's what I will do. Now, the thing here is I need to add the 4. Can I add the 4? No, I can't add the 4. But what is another way to add the 4? That's when we know that to use the 5. Remember, if we want to plus the 4, it's equal to plus the 5 minus 1. So we build on top of when we learn how to add the 5, we build and how to add the 10. So it's a whole framework to critically think what are the steps to do. So now we can do is we can plus the 5, take away the 1. And now I'm going to take away the 3. Nuts! I don't have enough beats to take away the 3. So what do? What is another way to take away the 3? I notice I could take away the 3 is take away the 10 minus or plus the 7. Oh, this is another two-step equation. How do I know? Because now, right here, I want to take away the 10. Notice the 10 and the 1 is very similar. Minus 1 and minus 10, it just depends on where the column is, right? So what's another way to minus the 1? Minus the 1 is equal to minus the 5 plus the 4. There's a lot of equations, a lot of formulas floating around. But if you understand how they all work, then it's very easy. Don't forget, this is, depending on how long you've been with me, this is not going to be ingrained. But when you continue to go through the Abacus method, it will become more ingrained. So here, I'm going to add the 5, take away the 5, add the 4, and I need to add the 7. So I add the 7. Is there enough? Yeah. So I need to plus the 7, plus the 5, and then the 2, and I add it together like that. So my answer is, anybody know what my answer is? What is my answer? Again, if I start with my 1s, my 10s, my 100s, the top beat is a value of 5. What is my answer on my abacus? Anybody know? Thank you so much for the likes. Hi. Oh, hi Impact. Thank you for the heart. I don't see it when it happens. I'm sorry. But thank you again. Hi Leanne. So we're trying to read what this is. What number is this? Anybody know? 148. Yes, Optimus Subprime, you're back. Yes, 148. And now it's getting all crunched up. But that's the idea. So what's the thing is to really understand the formulas. When you understand the 5 formulas and the 10 formulas, then you can mix the two and just everybody's really happy going, and everybody sings kumbaya. It's fantastic. And honestly, if you know the 5s and the 10s, everything makes sense. It just depends on who goes where and what happens. And that's what I'm saying. Knowing the 5s and knowing the 10s is like the ingredients of eggs and milk and what you want to do with it. Do you want to make a soup base, like a creamy soup? Or do you want to make a cake? Then you just add flour, right? If you want to make cookies, you add flour and sugar. If you want to add, but the base, the fundamental base, unless you're lactose intolerant, would be the milk and the egg. Those are the critical ingredients for everything in adding and subtracting, if that makes sense. Yeah. So we can continue on doing some more addition and subtraction, or we can go on to wow, it's been an hour. I feel like I don't talk so much. So there was that, and then there was the +5. Oh, so let me continue on with. So this book is the book after the preschool book. Now the reason why I had this one was I made it so then the kids would understand why we would be making a 5. Because I do realize that making a 5 is a little bit of a different concept. So what I did was I have it where I have a little story that what we want to do is if we need to add a 5, we have to go. Oh, that was the thing. If we go to so here's my question. 2, I'm going to do this one over here. 2, because it's easier to see, right? So I'm going to do 2, and then I want to add the 4. Now, I'm going to go to the cats in the tree. The cats in the tree has 5, just like my fingers, right? The cats in the tree has 5. So I'm going to go to the cats in the tree, and I add 5. But what do? I'm trying to add 4. So I get 4 cats. If you notice my hand, I grab 4 cats. 1 cat runs away. So I have to take away the 1 cat. So my answer is 6. And I thought that was a really interesting, like manipulative, like using your fingers and using your hands to show what we're trying to do. So if you notice, and again, we could do it again for the plus 3. So if I do a plus 3, I want to add 4. Again, we're focusing on the second add-in, right? The second add-in is add the 4. So when I want to add the 4, there's not enough beads. So I got to go to the cats in the tree. So I take my hand out, I go to the cats in the tree, and I add 4. But one cat runs away. My thumb runs away. And so I take away 1. So my answer is 7. Yeah. I mean, there's a lot of, I don't know if that's a strategy. But it's something that kids can see and something that kids can be able to like understand and stuff. So that was the one thing. And again, we focus on the second add-in, which is this. The second add-in is the plus 4, the plus 3, the plus 2, and then the plus 1. I did not skip plus 1. There is a plus 1. But plus 1 only has like one question. So if you look, there's only one question for plus 4. There's not very many you could do. But 2, there's 2 questions, and 3 there's 3, and then 4 there's 4 questions. So it's just interesting how everything goes. But if you notice, if we start going down, right? If we start going down, 5 plus 1 is not a formula. 6 plus 1 is not a formula. So when we look at it, when we add 6 and then plus 1, that's not a formula. But it is when you get to 9. Why? Because now we have no more beads to add the 1. Yes, do I sell the book? Yes, I do sell the book. It is available on Amazon. You can search for my name. I'm trying to upload it to the TikTok shop, but I haven't done that yet because I'm still trying to figure out how to do the TikTok shop. But this is available on Amazon. I do have these ones. I'm up to right now. I'm working on book 7, which would be the introduction to Abacus. It won't be as cutesy and as big because this one is 220 pages, and this one was focusing on doing bead recognition and number recognition. So what I wanted to do is for people who already know what the numbers are, we don't need to focus on who's bigger and who's smaller, and I don't need to focus in on how to trace. So there's going to be another book I'm in the process of making, and what we're going to be doing is we're going to be doing bead recognition. One of the activities was going to look like this, and you will get a sample of it. Woo! Anyways, so I was working with my one student, and I wanted him to really understand what it would be like, how to read it. So that's why I was focusing on this. So this is simple adding, right? We have our number, we have our 1, and the idea was to get the representative, because if I change it to a symbol, then it's too easy, right? What I want him to do is I want him to get to understand how to look at the abacus. So I have the 1, and then I want to do 2, so I add 2 beads, and then I get 3. And that was, again, number recognition. And then I'm going to add in these mazes. The mazes, again, is only for number recognition. It's not going to be like 20 of these. There's probably going to be like 5 of them or whatever. And the idea here was, if I look at this number, what number is this? And so I can color it in. What am I doing? I'm cleaning up my stuff. I have too much stuff. So here, I want to color in the beads. So I have 5 bead here and then 1 bead here. I know this is 6. So now what I got to do is I got to figure out where's my path, and my path goes down here. So the idea was, one, to make it to color it in, right? And the biggest purpose of this was to do bead recognition and what the number is. So then here, what number is this? Somebody tell me what number this is. Hi, Amma. Thank you so much for sharing my live. So what number is this? Right? So this is, again, bead recognition, and this is the representation. Yes, thank you, Optimus Subprime. So yeah, this would be 2, and again, we just follow the path. So the idea was to be engaging and just to, to kind of not be so monotonous. But then that was the idea. So the beginning of this, this would be the beginning of understanding, and then the idea was once we understand how to read it, it would be going into adding and subtracting, and then after adding and subtracting, then it will go into this. But I do plan on making a more less less childish, but I still have the activities. Like I wouldn't need to add in the cats in the tree. I would just be adding in the yes, green pill. That is correct. It's two. What I would be like, I wouldn't be adding in this part. I would just be talking about how the formulas would look. So that's where the plus 10 would come in. And plus 10 was my latest book, and in here I have a better explanation of how to add the 10 on the abacus. So here I was showing, like, in the adult book or in, like, an older book, I wouldn't be adding. You know what? I'm going to add this where plus the 4 and plus 6 is equal to 10. And what we're going to do is we're going to maneuver it around so we rearrange it to look like this. When we rearrange it, this is the formula that we need to memorize. When we memorize this formula, that's because I like pictures, and pictures are pretty. So I like to know that I want to add the 10 and I take away the 6. So that's what that means. I want to add the 10 and then take away the 6. And this is the sample question. So here is 9. Where's my abacus? So here's a question. If I want to add the 9 and I want to plus the 4, there's not enough beats to add the 4. So what do? I go to my formula, which is plus the 10. Again, remember, plus the 10 is only the go to the next column, and then take away 6. Oh, can I take away 6? Yeah. So 6 is one beat on top and one beat on the bottom, and you move it together like that. And so my answer is 13. So yeah, I mean, there's been interests after, like, to make it more adult. So I didn't think that anybody would care, but I'm excited to continue down this path and sharing it with everybody else. But I will planning on having more activities, like, practice the plus threes, and then I still like the spinning wheel, and I would still probably keep it in. And what does a spinning wheel do? Well, the idea is to get a paper clip. Let me get my paper clip. Let me get to a better, yeah. And the idea was you take the paper clip, and I'm going to take a pencil and you spin it. And I land here. So then I'll add the 9 to here. And then here is where I put in write the formula that I'm using, and then I do the question. So if I find my abacus, so I find my abacus, here is 19. I put 19 on my abacus, 19, and then I add the 6. So when I add the 6, I don't have enough. What do? I plus the 6 is equal to plus the 10 minus the 4. So again, the information is from the previous, right? And this is where we talk about plus 6. So we say, and then this is where you practice and you write plus the 6 is equal to plus the 10 minus the 4. So what I'm going to do is I'm going to plus the 10 and I take away the 4. So my answer is 25. So that's this book. And then I'm in the process of, so that's what it is. And then these are the other books that I have. One is a coloring book. This is just to be fun, having some fun with the coloring book. It was really boring, like, in the beginning, because, like, I'm not a coloring book kind of person. But I was like, you know what, I'm going to add a coloring book. And I was like, you know what, this is kind of boring, like, okay, I was trying to do two-tone, but this is pencil crayon, right? But then I started looking at other people when they do, like, their coloring and stuff, and they got really fancy, and I'm like, whoa, that's really fancy, but I'm not fancy like that. So I just took whatever colors that I had and whatever crayons that I had, and I just started being a little bit more creative. So this is as creative as I get, just so you know. And I was just trying to do other ways and other things. I tried to do the painting one, but those paintbrushes are kind of a pain. I don't know. And then one of my son was trying to do this, and he kind of made a mistake with the rainbows and stuff, but he liked rainbows. I was trying to do, like, designs and stuff and so forth. And it goes to 100. And what I did, I mean, it doesn't go every number to 100. Like, after 30, it goes into tens. So we have 40, 50, 60, 70, 80 to 100. And if you're interested, I mean, this is also on Amazon as well. But I thought it was a little fun activity, but it wasn't going to be part of the curriculum. The other books that I have is more theme based, and this was just me being excited with Abacus. So I made it theme based because Abacus books that are out there. Again, this is a student. This is for children who don't know what their numbers are. But I also want to bring in the idea of what an abacus is. So here they have to trace the number 8. This is the 8, and then the idea was to follow the path. So here was 8, and I go down. I'm going to color it in. So I trace the number 8, right? And then I go down. So I'm going to color it in blue. So I'm going to color in this box. And then I have this one. This one is 8. How do I know? 5, 6, 7, 8. Ooh, I did that wrong. I should have did it with the red. But the idea was it's a maze, and follow the 8. So you have to find all the 8s. It could be a number, it could be an abacus, it could be a word, or it could be a blank spot. This blank spot is meant for dough balls, which one of the activities was to make 8 little things out of Play-Doh. I didn't use the word Play-Doh because Play-Doh is a trademark, so I said dough balls. So the idea was to grab their Play-Doh and to get them to exercise their little fingers and create 8 balls. And then that was the idea. So that was the idea for this maze. But this one only talks about going from 0 to 10, and this is only about number and bead recognition. We don't do adding and subtracting, but here I have like cutting and tracing, and so this was to practice their fine motor skills. So, and then again, there was more tracing and connecting, how to match the two. So you find the one, and then you find the abacus. So this was more matching. Oh, so here's an example of an not older, this is what's out there right now. This is an abacus book. This is not mine, but, well, it's mine that I purchased, but this is not my abacus. Anyways, so if you know, this is what my kids grew up with, and it was really quite boring because if you notice, one page is 60 questions. I don't know about you, but it gets a little mind-numbing if you don't have anything except for moving the beads. So, I mean, it gets kind of like really monotonous. So I was trying to modernize Abacus, and I wanted to modernize it and make it more interactive, and so that's what these were for. And I noticed that there was a gap, and that was one of the gaps, was to make Abacus more modern and to be more fun. And then my last book that I have on my bookshelf right now is the Christmas counting, but then the Christmas counting I actually do adding and subtracting. So here I added saying it's for adding and subtracting depending on how old the kids are. Ages 3 can still do it because I still walk them through like tracing and looking at the numbers and looking at the things. So obviously when I talk about the introduction to Abacus, I won't have tracing. I'll go straight into one is doing the bead recognition like this, but this one is also specific too because it says here, this is the beads, right? So there's a 1 bead here and there's a 3 bead here, and there's like the question is what's the bead in the middle? So that, and then we had to find the numbers here. So this is still about understanding the concept of where the numbers go. I wouldn't do this. I would probably just do the bead itself. So if I had 1, find the 1. If I had 4, find the 4. I would be doing more bead recognition for the introduction one. And then this is the adding and subtracting. Yeah. And I kind of like it because now we have double digits, right? That's because we can start talking about the plus 10s and the minus 10s, and it'd be an easier transition. So that's what it was. And then there's big brain notes in the Christmas one. If you want to do Christmas, that's fine. If you're okay with being it themed, but it was interesting to go through this motion of building the books to align with mainstream math. Yeah. Anybody have any questions? And again, there was more tracing, and then I did the numbers to try to relate to it. But yeah. Anybody have any questions? Thank you so much for sharing my life. Oh, thank you, Amma, for sending me a heart. I just saw that. Yeah. Anybody have any questions? I can continue on, but I think I think it's time to take a little break and have some dinner. It's a little late. Right now, I'm in Pacific Standard Time, so it's 7 o'clock for me. So I think it's time for me to see what the kids are doing and see if they're hungry. But yeah, if my books are available on Amazon, I'm planning on publishing a few more. It just depends on the time and stuff. So if nobody else has any other questions, let me. I will see you guys in the next live. Yes, thank you for joining me. Thank you again for joining, and I hope it was helpful. Thank you. Thank you for sharing. Any Abacus Rex for a toddler? Any? So your toddler? How old's your toddler? I would recommend the colorful one. I would not recommend the one that has a solid color. Oh, thank you so much. I would not recommend the one that has all of the one color. What I would do is I would keep it like this because the top bead has a significance. Almost 3. Oh, that's the best age. So just so you know, it might take you a year to go through the book because I mean, if you do like a page a day, that's great. It's meant to just kind of practice and get it kind of anyways. I'm trying to like think of the words, but I had a student. I have a student, and he's been with me for a year, and it's still taking him about a year to actually understand how to read the beats. So I wouldn't rush it, just so you know. But it also depends on like your interaction. Anyways, the yeah. So I would recommend to get this one. If you want to, you can get the 13 column one, but I think when he or she gets older, when your toddler gets older, they might get tired of the colors. So you might want to graduate them later to a 13 column with the single color. That's what I would probably do. I would probably start with this first and like the 7 column one, and then when they get into it, when they do multiplication division, then I would transition them to this one, because the problem is when you do multiplication division, there's not enough columns to add. So I would graduate them to a 13 column one, and this would be plenty. You could do the big one like I had, the competition one, but I feel like that's overkill unless you want to do competition. I feel like that this is overkill, and I think this is going for like maybe $50. I don't know. I mean, this is an old Abacus. I've been doing Abacus for about 20 plus years. So when I got this one was 20 plus years ago. Do they sell these ones anymore? They might, but it might be expensive. This one is actually real bamboo, whereas this one is plastic, and it's perfectly fine because what you want is you want the beads to move well. If you notice that, you want the beads to move well. There is another one you have to be careful. It's called the Kramer Abacus. It looks exactly the same, but it's a little bit tougher to move because those are the ones for people who are blind. So there's one that's called the Kramer Abacus. And then also remember that you're looking for the 1 bead on top and the 4 beads on the bottom. You might see the Chinese one, which is 2 beads on top and 5 beads on the bottom. If you want to, you could, but I would recommend try to stick with this one. So these were the two I would recommend. Something with the blue beads on the top and then the colorful beads in the middle, or the bottom beads. That's what I would recommend. Yeah, sure, no problem. Let me know if you have any more questions. I also do office hours like regularly on my YouTube channel, and you can ask me any questions. I do have one parent that comes through my school, my class. She does the online, and it's an online pre-recorded, but she has questions, and so I'll answer questions like specifically what she has questions on. Like her child is 7 years old, and she had questions like, can I do certain things? And I'm like, I would refrain from testing them right now because they need to go through the motions of understanding how to use the abacus. Once they understand, then everything will start to go into long-term memory, and then from there you'll be able to test them. So like right now, my kids are old, right? I can test them. Would they pass? I don't know, because it's been a while since they've learned abacus. They've done abacus, but it's one of those things that you practice on a daily basis. Even if you had like, when you start counting anything, you can say, okay, this is 1 pen. That's what 1 would look like on the abacus. So I would relate as much as you can. Anytime you're talking about math or numbers, relate it to the abacus so the transition is easier, and it's just part of when they start learning. So if that helps, I hope that helps. But that's how I started. Is I got the kids to be like, okay, if we're talking about two pens, what does two look like on the abacus? Actually, I take that back. I didn't do that with my kids because I was a young parent, and I had a full-time job, and learning abacus was just one of those things like, you know what, just do it. But I made it more fun now, but my kids don't do any of this because they're too old to do it. So, okay, thank you everybody for joining. It's an hour and 15. I didn't want to spend too much time taking up your time, but I'm going to go for my dinner. Probably go downstairs and see what's for dinner. Thank you again for joining me, and I'll see you on my next live. Thank you again. Come, you know what? If you have any more questions, come with questions. If you want to learn how to do multiplication, division, and so forth, we could talk about all of that. I am game. I am game for all of that. And we can do decimals as well. But that's as far as it goes. We don't do fractions because you'd have to divide it out. Okay, again, I'm going to stop talking. I should stop talking because I can go on, but I should. Okay, thank you again. Thank you. And I'll see you guys in the next live. Toodaloo, kangaroo.